Egg Grading Manual, Agricultural Handbook number 75, Chapter 2, Production and Maintenance of Egg Quality. Egg production has been and continues to be a major agricultural industry in the United States. In 1999, total egg production was almost 7 billion dozen. The North Central area continues to lead the nation in production, followed by the West and the Middle Atlantic areas. Producing and marketing this volume of quality eggs have been accompanied by specialization in the areas of breeding, hatching chicks, raising chickens, producing eggs, and producing poultry meat. Large vertically integrated firms that perform several or all of these functions have become most prominent. The average block size for an operation often exceeds 75,000 layers, with many over 1 million. Production is either offline or inline. Offline production refers to processing operations that are not integrated with a laying facility. Offline eggs are gathered and shipped in from laying facilities at other locations. Inline production refers to processing operations where eggs are laid, processed, packed, and shipped from one location. Most production facilities today are large, integrated inline operations. An understanding of egg production practices will help processors and quality control personnel contend with product quality issues. Breeding. The white leghorn is the predominant breed of layer being raised, in part because it lays white shell eggs. Brown shell eggs are available in some parts of the country, but white shell eggs are more widely demanded by consumers. Shell color and thickness, egg size, quality, and quantity of thick white, quantity of eggs produced, and to some extent, freedom from blood spots are hereditary factors that affect overall egg quality. For example, broken and cracked eggshells are directly related to shell thickness and strength and have great economic impact on the industry. Also, a reduction in shell quality is a direct result of increased egg production. Over time, improvements in these hereditary factors have been bred into the white leghorn. Chicks or pullets for the initial flock or flock replacement should be procured from a source that can give reasonable assurance that these factors have been carefully considered in the breeding program. Hatching. To promote improved breeding and production qualities in poultry and to reduce losses from pullerum disease, the industry established the National Poultry Improvement Plan in 1935. Today, NPIP is administered jointly by USDA's Agricultural Research Service and an official state agency in each of the cooperating states. It operates according to regulations and standards developed to provide assistance to breeders and hatcheries in producing birds free from egg-transmitted diseases. Procurement of chicks from plan hatcheries assists the producer in the selection of desirable young stock. In 1989, NPIP developed a Salmonella enteritis control program to reduce the incidence of SE in hatching eggs and chicks. Participants in this program follow designated control procedures and practices at breeder farms and hatcheries. Brooding and raising. Some operators brood chicks and raise them to laying age, while others purchase 16 to 20-week-old birds from specialists in the pullet raising field. The brooding period usually involves the first 6 to 8 weeks of the chick's life and is the most critical period for the bird in reaching its full potential. Temperature, feed, water, and environmental stress must be controlled and monitored continuously. A properly managed feeding program assures uniform growth and a manageable egg production schedule. The intensity and duration of light during the brooding and grow-out period have a dramatic effect on growth and sexual maturity. Today, most brooding and grow-out operations are environmentally controlled, which means the lighting and other factors can be automatically controlled for optimum development. Years ago, many producers utilized the practice of culling flocks. Culling is the careful evaluation, either visual or physical, of a flock to remove birds that are diseased or weak and cannot reach their full level of production. Modern breeding and production technology has virtually eliminated the need for culling. Today, most layers are kept in production for a laying period of 12 to 14 months unless they are force molted. Molting is the natural loss of feathers that generally occurs annually late in the summer. During the molting period, which usually lasts 45 to 60 days, egg production stops and the chicken's reproductive system rejuvenates. Force molting is a controlled production practice that, depending on the current economic situation, can have a significant effect on production income. Cost of feed, egg prices, and cost of layer replacements are factors that must be considered before committing to a forced molting program. Forced molting is usually induced by a withdrawal of feed followed by a low protein, high calcium diet until production resumes. Housing. Proper housing is essential for efficient egg production. Birds that are comfortable are healthier than birds kept under improper conditions, and production costs are lower. Environmental temperatures and air circulation are critical, with the optimum temperature being between 57 degrees and 79 degrees Fahrenheit. Temperatures outside this range affect feed conversion, egg production, egg quality, and water consumption. Waterers and feeders, whether the manual or mechanical type, should be kept clean. Dirt and dust should be held to a minimum. Controlled ventilation and, where necessary, adequate insulation should be provided to have the proper temperature and humidity conditions. Overcrowding should be avoided, and the equipment and facilities should be kept in good condition. Currently, over 90% of all table eggs produced in the United States are from caged layers, primarily because of economics. Eggs produced in cages cost less to produce than those in floor systems due to much more intensive labor and floor space requirements with the latter. Most new operations are environmentally controlled, multiple level cage systems that are completely automated with mechanical feeding and watering equipment and conveyor belts that carry the eggs out of the laying house. Environmental housing also provides a method of controlling temperature, light, and humidity. Additionally, controlled housing provides protection from predators and disease-carrying rodents and pests. Feeding shares the limelight with breeding and the production of high-quality eggs. With recent advances in poultry nutrition and the use of computers for formulating, a dozen eggs can be produced at less than 4 pounds of feed. Feed formulas with varying protein levels are adjusted based on the season, age of the birds, and the availability of specific grains. Shell. The breaking strength of an eggshell is affected by feed, breeding, age, freedom from disease, and hot weather. Today, the average commercial feed supplemented with grit usually has sufficient calcium, phosphorus, manganese, and vitamin D to produce sound shells. The source of shell trouble is more frequently found in other factors mentioned. Yolk. Dark pigmentation in the yolk affects the acceptability of the egg in the top qualities. Rations high in yellow grains and green feeds produce dark yellow to orange colored yolks. Rations high in green grasses, silage, and cottonseed meals will cause the yolks to acquire a reddish or olive color. Off flavors may be from feed formulated with a poor quality fish meal or other contaminants in the feed. White albumin. To be of top quality, eggs must have a high percentage of thick albumin. A lack of this factor can be attributed to breeding and disease of the chickens and to improper care of the egg after production. Low quality whites can also be attributed to high levels of ammonia gas in the laying houses due to improper ventilation. Care of the eggs on the farm. Immediately after it is laid, an egg begins to lose quality, even if it is removed from the nest, cooled, packed, and marketed promptly. Keeping temperature and humidity conditions at an optimum level retards this loss in quality to a large degree. Although most eggs are produced by a large inline integrated operations, some are still produced from offline production facilities. At offline sites, certain steps are necessary to maintain egg quality at the highest level. Some of these steps are: gather eggs frequently, at least 3 times a day, handle the eggs carefully to prevent breakage, cool the eggs promptly and store them under the optimum temperature and humidity. Pack the eggs in clean, cool packing materials. Pack clean eggs separately from dirty eggs. The high-quality egg produced under today's large-scale integrated flock system lends itself well to handling and processing by automatic equipment. In fact, most new complexes are inline systems designed to carry eggs from the henhouse to the carton in one continuous operation. Eggs must be handled properly throughout each phase of production, processing, and transportation to maintain quality. Washing equipment washes, sanitizes, and dries eggs automatically. Grading equipment uses mass scanners to help operators detect and remove dirties, checks, irregular shells, meat and blood spots, and lost eggs. Automatic weighing equipment individually weighs each egg and sorts the eggs according to the official weight class. Automatic packaging equipment places the eggs into cartons, closes the cartons, and stamps the cartons with a production code. Coolers reduce the temperature of the eggs and maintain humidity levels that minimize quality deterioration. In addition to people doing quality control work, plants occasionally conduct quality segregation by hand candling. In these situations, adequate facilities and equipment must be provided in order to grade eggs with maximum efficiency. Building and premises. Maintaining a sanitary food environment is an integral part of processing quality eggs. The design of the building and layout of the premises should provide suitable environmental conditions, permit adequate cleaning, minimize contamination, prevent access and breeding of pests, and provide an adequate space to accommodate the processing operation. The premises should be clean and free of trash, debris, and old equipment and supplies to discourage and eliminate the presence of insects and pests and reduce the possibility of cross-contamination. Areas surrounding the plant should be properly graded and free of standing water, free of tall grass or weeds, and kept reasonably clean. The floors, walls, and ceilings of buildings should be constructed of materials that are durable and smooth, and that can be kept clean, sanitary, and in good repair. Processing room floors should be properly sloped for drainage and constructed of materials that are smooth, impervious to moisture, cleanable, unresistant to chemical cleaning compounds. Doors and windows leading to the outside should be kept closed or fitted with tight-fitting screens that remain closed when not in use. Adequate ventilation is to be provided to control humidity and provide comfortable year-round working temperatures. All rooms should be kept clean and sanitary at all times. Waste collection and disposal is important in maintaining an environment free of objectionable odors and pests. Refuse containers used in the processing room should be emptied and cleaned daily. Refuse generated from the processing operation should be removed from the processing area daily or more often if needed, and stored in covered receptacles or compactors. Separate areas should be provided for the storage of packing, and packaging materials, chemical compounds, and insecticides and rodenticides. Chemicals should be stored separately from edible food areas and properly identified to prevent any accidental contamination of the eggs. All materials should be stored away from walls to facilitate cleaning and pest control. Washing, grading, packing operations, and equipment. Even with good farm management practices and careful handling, a small percentage of dirty eggs will be produced. Producers must bear in mind that dirty eggs are covered with bacteria that will cause spoilage if they enter the egg. Whether conducted at the production or processing site, washing must be performed in a manner that will minimize the chances of bacterial penetration of the shell. If these important facts are forgotten and eggs are washed carelessly, more damage can be done than by leaving the dirt on the shell. Wetting a dirty shell provides moisture in which bacteria may breed and assist their growth and penetration through the shell. A washing solution colder than the egg causes the egg content to contract and thus allows polluted water to be drawn through the shell. When washing eggs, the following precautions should be followed. Wash eggs with water at least 20 degrees Fahrenheit warmer than the internal temperature of the eggs and at a minimum of 90 degrees Fahrenheit. Select a detergent or detergent sanitizer that is compatible with the wash water and one that will not give off foreign odors that may be imparted to the egg. Use only potable water with an iron content of less than 2 parts per million for washing and keep wash water as clean as possible. Rinse by spraying with water slightly warmer than the wash water. Use an approved sanitizer in the spray rinse. Dry the eggs to remove any excess moisture prior to packaging. After washing, eggs should be rinsed with warm water spray containing an approved chemical sanitizer to remove any remaining bacteria. The strength of the sanitizing spray should be no less than 50 parts per million, nor more than 200 parts per million of available chlorine or its equivalent. Research has shown that during the washing process, most of the outer cuticle on the eggshell is removed. Removal of this cuticle increases the rate of carbon dioxide. Removal of this cuticle increases the rate of carbon dioxide and moisture loss of the internal egg contents. To reduce the rate of loss, spraying the eggs with a light coating of food-grade mineral oil is a common practice. For best results, the entire oiling system, including spray nozzles, filters, and oil storage reservoir, should be checked frequently to assure that the equipment is functioning adequately and that the oil is free from contamination. Most offline eggs are packed in practice filler flats, palletized, and transported to the processing facility. This procedure provides the most effective method of handling and cooling offline eggs prior to processing. Since plastic flats are used repeatedly to transport unprocessed eggs, the incidence of bacterial cross-contamination is enhanced. To avoid cross-contamination and the creation of an unsanitary condition, place plastic flats should be thoroughly cleaned and dried after each use. To facilitate the cleaning process, modern processing plants typically install and utilize plastic flat washing and drying equipment. All processing equipment should be designed and constructed of such materials and workmanship so as to be smooth and easily cleanable, and to preclude the adulteration of eggs with foreign materials. Egg washing, sanitizing, and oiling should be conducted according to the procedures outlined in the current regulations governing the voluntary grading of shell eggs. All equipment and processing rooms should be thoroughly cleaned at the end of each processing day and should remain reasonably clean throughout the processing shift. The distance of processing equipment from walls and the space between equipment should be enough to provide room for cleaning, maintenance, and inspection. The space will vary greatly depending on the type of operation and capacity needed for the amount of product handled. Sufficient overhead light should be provided to facilitate cleaning the room. The candling area should be darkened to the extent necessary to do an efficient job. The extent of darkness will vary depending on the type of processing equipment used. The light rays from the mascanning area should be diverted away from the candler's eyes. On high production machines, it is generally best for a candler to also have another type of job assignment to prevent eye strain, break the monotony, and improve efficiency of the candling operations. Recent advances in processing technologies have resulted in the development and use of candling equipment that can electronically remove most undergrade type eggs. After candling, individual eggs are weighed using mechanical or electronical weighing equipment. Most modern processing equipment integrates weighing as an inline component of the processing machine. The weighed eggs are segregated by weight class and conveyed to the applicable size packing line. Packaging and packing are normally carried on in conjunction with the grading operation. Clean packaging and packing materials should ensure adequate protection of the product in the handling required in the grade station, distribution channels, and the retail store. Cartons or filler flats of eggs should be placed on conveyors gently and carefully moved to the packing station to minimize any additional breakage. Packaging materials should be new and free of mold, mustiness, or any other off odors or condition. Packing materials such as wire or plastic baskets or transport containers such as metal racks should be reasonably clean and free of egg meat before use. Cooling facilities. After eggs are graded and packed in cases, they should immediately be moved to the shipping room cooler and held there until ready for distribution. Cooler rooms should be free from objectionable odors and mold and should be maintained in a sanitary condition at all times. The coolers must be capable of maintaining the temperature and humidity necessary for the preservation of eggs. Coolers should be equipped with thermometers and hygrometers to verify and monitor temperature and humidity. Coolers for unprocessed eggs should be capable of maintaining an ambient temperature of 60 degrees Fahrenheit or lower. Processed egg coolers must be capable of maintaining an ambient temperature of 45 degrees Fahrenheit or lower. All coolers should be capable of maintaining a relative humidity of 70 to 85%. Every reasonable precaution should be exercised to prevent sweating of eggs when there is condensation or moisture on the shell, in order to avoid smearing and staining the shell and to inhibit the growth of bacteria on the shell. Egg sweating is usually caused when eggs are moved from a very cool environment to an environment with a moderate temperature. For example, from an unprocessed egg cooler to the processing room. This is why it is impractical for unprocessed eggs to be held in coolers for long periods of time with temperatures lower than 50 degrees Fahrenheit. Health and cleanliness of employees. Employees handling eggs should take every precaution to prevent cross-contamination between production and processing areas. Traffic patterns of employees should be reviewed by management to avoid cross-contamination. Employees assigned to work in production areas should not be allowed to work in processing areas unless the necessary facilities are available for cleaning and changing clothes. Clean outer garments should be worn when employees are processing eggs. All employees should wash their hands before beginning work and upon returning to work after using restrooms, eating, smoking, or otherwise soiling their hands. Hand washing facilities should be provided in restrooms and processing areas. Persons afflicted with or who are carriers of a communicable disease should not be permitted in any room where eggs are processed or otherwise handled. Persons with discharging or infected wounds, sores, or lesions on hands, arms, or other exposed portions of the body should not be allowed to work in any processing room where there is contact with eggs, processing equipment, or packing of packaging supplies. Distribution wholesale. Eggs for wholesale outlets should be packed in new packaging and packing materials. The majority of shipments today are by refrigerated truck. Trucks hauling eggs must be refrigerated and well insulated on all surfaces and doors to maintain quality during warm weather. The loss of moisture during transportation can be minimized by pre-cooling the transport vehicle prior to loading and transporting the eggs. In addition, since wholesale eggs are generally packed in fiberboard boxes with few, if any, vent holes, it is extremely important to pre-cool the eggs to a uniform temperature prior to loading. A refrigerated truck should be used for summer deliveries and a well-insulated truck for winter deliveries, equipped with a warm air heating unit for extreme conditions. Truck beds should be equipped with racks to provide uniform air circulation around the load. Before loading, trucks should be checked to make sure that the interior is clean and free from foreign odors, and that there are no breaks in the walls, ceilings, or floor surfaces. Retail. High quality eggs that have been properly cared for during packing and transportation are sometimes handled carelessly by the retailer. Proper stock control and care, including volume delivery, rotation of supply, adequate refrigerated holding areas, and proper humidity are necessary. Bulk stock should be stored only under refrigeration in a space that is free from volatile odors of any kind. To promote consumer satisfaction, eggs should be packed in attractive cartons, be uniform in size and weight, and be of high interior quality. Improper handling at any point during distribution and marketing will result in lower overall quality and diminished consumer acceptance.